Hello everyone, this is Ketish here. In this video, I'm going to go through the 2023 Physics Paper 2 Foundation tier for Combined Science. The Foundation tier Paper 2 is also 1 hour 15 minutes and it's got 7 questions. And it's being tested on 3 main topics: forces, waves, and magnetism and electromagnetism. So let's have a look at question number 1. Figure 1 shows a garden chair hanging from a spring. The weight of the person causes the spring to extend. So, as you can see on the top here, the spring's over here and the weight is causing the spring to extend, means it's getting longer. Why does the weight of the person cause the spring to extend? Tick one box. Weight acts downwards, weight acts in all directions, weight acts upwards. The main reason it extends is because weight is acting downwards, which is pulling the spring downwards. So the weight is actually acting in this direction, which is causing the spring to be pulled in this direction, to be extended. 1.2. Complete the sentence. Choose the answer from the box. The weight of the person in figure 1 is what force? The weight is a gravitational force. Gravitational force. Next part. The weight of the person causes an extension in the spring of 0.07 meters. So that's the extension. The spring constant of the spring is 12,000 Newton per meter. Calculate the weight of the person. Use the equation below. So they have given you the equation: weight equals spring constant multiplied by the extension. So they're asking you to calculate the weight, so there's no need to rearrange the equation. The spring constant is 12,000 multiplied by the extension 0.07. Let's bring up the calculator for this so you can see how it's done using the calculator. Right, so 12,000 multiplied by 0.070, and that gives you 840 Newton. 40 Newton. Calculate the elastic potential energy in the extended spring. So use the equation: elastic potential energy equals 0.5 multiplied by the spring constant. Again, here you don't have to rearrange the equation. Spring constant, remember, it was 12,500. Is it 12,500 or 12,000? 12,000. Sorry, 12,000 multiplied by the extension squared. Now that small 2 means it's the square. So 0.070 squared. So how do we do this in the calculator? That 0.5 times 12,000 times 0.07. Square means to multiply it again by 0.07. Multiply that by 0.070, and that gives me 29.4. So 29.4 joules. Question 1.5. If there is no more than one person on the chair, the spring could become inelastically deformed. And if you put too much weight, right, if there is more than one person on the chair, the spring will become inelastically deformed. What is meant by inelastically deformed? The spring extends more when two or more forces act on it. That's not it. The spring will not go back to its original length when the force is removed. That is correct. The spring extends so that it is twice as long as the original length. No. Inelastically deformed is when something changes shape, but it won't actually go back to its original shape. Question 1.6. The manufacturer of the chair investigated the extension of a new spring. Figure 2 shows slotted masses hanging from the spring. The weight of the masses extends the spring. So as you can see, the masses are hanging on the spring and it's actually pulling the spring and it's making it longer. So that's the original spring without any mass, and the second diagram is with the masses. Which length in figure 2 represents the extension of the spring? The extension of the spring is that extra length. So here A is the original length, right? A is the original length. C is the extension or the length of the spring with the masses. So you can say new length. The extension is this extra bit, which is B. If you add A and B, it should add up to C. So the answer is B. Figure 1.7. Which graph shows the extension of a spring is directly proportional to the force applied to the spring? What does directly proportional mean? Directly proportional is when you double something, for example, like the force on the spring, the extension will also double. Right? They are proportional, right? But in equal amounts. That's why we say directly proportional is when you double one value, the other value also doubles in a graph. So what would the graph actually look like? The graph would have a straight line, right? So that means it's not C here. And the graph would also go through the origin, which is 0 here. And it'll actually go through right in the middle. So that's directly proportional. Question 1.8. Table 1 shows the results of the manufacturer's investigation. Suggests 2 improvements to the investigation. So the manufacturer did 2 investigations, one with 100 Newton and then with 200 Newton, right? And they found the extension. What they want is for you to suggest 2 improvements to the investigation. Well, test for more forces, such as 300 Newton, 400 Newton, 500 Newton. And when you do an experiment, you want to have at least 5 different values. So rather than just doing twice, they could have actually done it for 3 different forces. And they seem to have only done it once for each force. Maybe they can actually repeat it 2 more times for 100 Newton, 2 more times for 200, so that they can get an average value. So we could say repeat 2 more times for each force and calculate a mean extension. Now there are also other improvements that you can make. Let me give you 2 more. So it looks like they've only tested one spring. So why not test other springs? So test other springs, meaning with different spring constants. And you could also test each spring or each spring's limit of proportionality. Meaning add enough force to find out at which point does the spring become inelastically deformed or when it will actually change shape. That brings us to the end of question number 1, and I will see you in question number